Here's a picture of one of these shipping containers from Rackable, one of the companies that makes them. Here's inside one of these containers. Here again is our 4th generation data center. And you just package everything in smaller units. Your shipping container comes with everything, the cooling, the networking, and the covering, so that they actually do not, they're completely modular. So this allows you to build in a much easier fashion scalable data centers. Here's another picture of this showing how it's arranged, and here's the actual where your shipping containers will plug in. Here's another picture of the Microsoft deployment across the globe, and these ones here are content distribution nodes. They're small nodes for getting the final answer to the users, and these things here are the actual major data centers. Here's some comments which I already started on green clouds, and cloud centers have put a lot of people building cloud centers have put a lot of effort into finding out how to make them more efficient, and that actual effort has gone into other centers which are now also much more efficient than they used to be. In a good cloud, there's an important quantity called power usage efficiency, PUE, and that's the total facility power over the IT equipment power. So this is IT equipment power is the power you really need just to run your CPUs and disks and things like that on your network routing nodes. So you have to have the IT equipment power at a minimum, but if you put in all the other things you need, the microwave for the system admins, the cooling, etc., you're going to need more power. So this ratio, PUE, is sort of a measure of efficiency. In days gone by, if you looked at that, it was actually around 3. Now, at least in a couple of years ago, it was 1.8. And clouds are in the range 1.1 to 1.2. And here is a link you can go to find out more about those 4th generation data centers with the improved power efficiency. It's rather difficult to find out how large everything is because the companies don't tell you, because it's a proprietary secret. There was a paper I found which somehow had managed to reverse engineer people's statements into measurements of sizes. And however, that paper was from 2010, so it's probably off some factor of 2 or something by now. And that in those days, there were 30 million servers around the world, and Google had almost 1 million servers, so that's 3% of the worldwide server population. Google had 200 megawatts of power used by those 1 million servers, and that was around less than 1% of the total power used in data centers. So they have 3% of the systems and use 1% of the power. That's the difference between a PUE of around 1 to a PUE of 3. It's worth noticing that Google used around 0.01% of the total power used on anything worldwide. Clouds are presumably a growing fraction of the world's server population, 20–30%. Is a little difficult to estimate how, because I think Amazon, Google, Microsoft, the large cloud companies, do not clearly publish the size of their systems. You can compare that with well-known high-performance computing systems. One of the largest system today, just recently, is the Chinese system built around the Intel Mic chip. Before that, one of the top supercomputers was the Blue Gene Q. That was the best about a year ago in summer 2012. That was 16 petaflops. and it had about 1 million chips with 1.6 million cores and say 1.6 petabytes of memory and 96 racks, and it used 8 megawatts of power. And at that time, which has now increased, the cloud data centers increased, you had 30 megawatts of power in the largest cloud data center and maybe 100,000 servers. So it's worth noticing the world's biggest supercomputer is around 2% of the total power of the cloud computing systems, and Google is around already has some 10 times the capability of the top supercomputer. And these numbers are clearly off by factors of 2 or probably 4. But they give you an idea as to what's going on. And we have a world where the largest supercomputer is perhaps 1% of the total server power. We have an individual cloud vendor with 10% of that total world power, and the total clouds are probably now 30 or maybe even 40% of the total computer server power. Here's another slide from a different talk on data centers versus supercomputers. So an earlier one before the Sequoia machine came out, it compares with the Blue Waters machine, the intended Blue Waters machine, which was 40K servers. And that at the time compared to a big cloud center with 100K 8-core servers. And it was worth noticing the difference of the networking. The supercomputer used InfiniBand with low latency, high bandwidth protocols. The data center was IP-based and is optimized not for internal networking, but for internet access. The data centers used memcache, disk on the node, and nearby blob storage. The supercomputers had separate data farms, and they used parallel file systems like GPFS or Lustre. So there is an important to notice there's different optimizations between cloud data centers and supercomputers, because supercomputers are being optimized to take a single job or a few jobs and run them as with the different nodes of the supercomputer working together on the same job, and that requires low latency in many types of applications. In the case of a data center, it's really optimized for many jobs. If they are running on the same, most jobs are running for the same problem as they are, for instance, in Google search applications or Bing applications. That optimization is a much looser coupling and is not network dominated. It's actually probably the search is probably disk dominated. And so you just need to, at some level, they're the same. Data centers and supercomputers are the same. Their computers and disks and networks all linked together. But the optimization are pretty different because the application aimed at are pretty different.